Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we have successfully finished the 10 lectures, right? So in a previous lecture that we have discussed about vector products, okay? And some of the important formulas based on the vector product, and at the end of the session, we have discussed some example problems, right? So in today's lecture that we are going to discuss about cosine law of vectors, sine law of vectors, and Lamis theorem, as well as at the end of the session that we are going to discuss some example problems based on Lamis theorem. Okay, important concept ma. So listen carefully and prepare the notes properly, right? So my name is Rakesh Kanganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. Shall we start the session? Okay, sir. Right. So what is the chapter going on? What is the chapter going on, ma? Motion in a plane. Motion in a plane. Okay, so what is the class number? So this is the class number 11, right? Okay, what is today's concept? Today's concept is first one, cosine law of vectors. What is that, ma? Cosine law of vectors. Cosine law of vectors. So this is our first topic, right? What is the meaning of cosine law of vectors? Have a look. So I'm taking a triangle. I'm taking one triangle. La 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 la. Okay. So this is a triangle, right? So let us consider this is a triangle A, B, C. A, B, C is the triangle. Okay, right, sir. I'm taking the angle between A and B side is a alpha. The angle between B and C side is a beta. The angle between C and A side is gamma. Any problem? I'm taking one triangle. So the sides of the triangle are A, B, C. Okay. So the angle between A and B side is alpha, B and C side is beta, and B and C and A side is gamma. Any problem? Right. So from cosine law, we can write cos alpha is equals to, we can write cos alpha is equals to a square plus b square minus c square by 2ab. A square plus b square minus c square by 2ab. So cos alpha, have a look. This is a alpha. This alpha is in between side a and side b. Have a look. Then I can write a square plus b square. With respect to this alpha, the side C is opposite side. That's why I'm taking minus C square divided by 2 into AB. Are you getting? Similarly, if you want to write the equation for cos beta, so cos beta is equals to, now beta is the angle between C and B sides. Then you can write B square plus C square, and the side which is opposite to beta is what, ma? A square minus A square divided by 2 into BC. Okay. So similarly, if you want to write an equation for cos gamma, so cos gamma is equals to, gamma is in between the sides C and A. Then we can write C square plus A square minus, what is the opposite side for gamma? B. B square divided by 2CA. 2CA. So these are the cosine laws based on given triangle. Okay, now so cosine law of vectors. So what is that? Cos alpha is equals to this one, cos beta is equals to this one, cos gamma is equals to this equation. And cosine law is valid for, cosine law is valid for any triangle. Any triangle. Okay. So these laws are valid for any triangle. Is it clear? Any doubts? Sir, we need a proof for this formula, sir. We need proof for this formulas. Okay, proof. Right. To prove cosine laws, I am taking the same triangle. Have a look. This is a side A, side B, and a side C. This is alpha, this is beta, and this is what, ma? Gamma, angle gamma. Now, at this time, I am representing the sides of your triangle in the form of vectors. In the form of vectors. Have a look. I am taking this vector as a bar vector. Have a look. This is a bar vector. Okay, right. So this side I am just considering as a b bar vector. Okay, so this is a b bar vector. Now this side I am considering as a C bar vector. So A bar vector, B bar vector, C bar vector. As we know from triangles law. So have a look. All these three vectors, A bar vector, B bar vector, and C bar vector are in order. Have a look. Head, tail, head, tail, head, tail. All are in order. Then their resultant. The vectors, the vectors, A bar, comma B bar, and C bar are in order. Are in order. Okay. The resultant. Then the resultant is given by. So resultant R bar is equals to, in general we can write. So three vectors are in order. A bar plus B bar plus C bar. And have a look. There is no closing side for this triangle. There is no closing side for this triangle. Then the resultant vector becomes 0. If you want to find the resultant of any two vectors, we have to take the two vectors in a order. And if you want to find the resultant, you have to take the another vector in reverse order. This gives what ma? Resultant vector. A bar vector and this is a B bar vector. Then have a look. These two vectors are in order. Then A bar plus B bar. This R bar vector in reverse order, and it gives the resultant of these two vectors. So this is what we are discussed in a triangles law. But in this case, have a look. These three vectors are in order. There is no closing side. There is no closing side for this triangle. So that's why the resultant of this triangle is equals to how much ma? 0, because no vector taken in reverse order to give the resultant of this vector. Okay, right. So the resultant bar is equals to 0. Then we can write R bar plus B bar plus C bar is equals to 0. So I'm just placing this A bar vector and B bar vector here itself only. So this is A bar vector and this is B bar vector, that is equals to, if plus C bar went to that side, it becomes minus C bar. Are you getting any doubts? Right. I'm just applying magnitude on either side. Apply magnitude on either side. So just apply the magnitude. So magnitude of A bar plus B bar is equals to magnitude of minus C bar. Magnitude of minus C bar. Have a look. A bar plus B bar magnitude. A bar plus B bar magnitude. So the resultant of two vectors R bar is equals to magnitude of A bar plus B bar is equals to, we can write under root of A square plus B square plus 2AB cos theta. So in a parallelogram law, okay, now we have discussed the addition of the two vectors. The resultant of addition of the two vectors is given by under root of A square plus B square plus 2AB cos theta. Same thing. Have a look. Magnitude of A plus B, magnitude of A plus B. So we can write this equation as under root of A square plus B square plus 2AB cos theta. That is equals to, so here magnitude of minus C is there. If any term is in magnitude with negative sign, if it is comes out from the magnitude, it becomes plus term. Are you getting any doubt? Simple mathematics, ma. Okay, right. Let's have a look. Above equation, squaring above equation on either side. I'm just squaring this equation on either side. So whenever we did the squaring on either side, what happened? Square root get cancelled out and this C bar becomes C square. So have a look. A square plus B square plus 2AB cos theta, that is equals to C square. Are you getting? What is theta here? Where theta is the angle between, theta is the angle between A bar and B bar vectors. Okay, theta is the angle between A bar and B bar vectors. Have a look. What is the angle between A bar and B bar vectors? Sir. Here A bar vector is there. Here B bar vector is there. Angle between them is alpha. Then here we have to take an angle alpha. That's it. You will get a wrong answer if you take an alpha, because in a second lecture, okay now, so parallel shifting of vectors, whenever you are finding the angle between any two vectors, you are finding the angle between any two vectors, you must consider the angle between either two heads or two tails. Have a look. This is the head of the A bar vector and this is the tail of the B bar vector. Never take the angle between head and tail. You should take the angle between two heads or two tails. For that, we have the concept, that is what ma? Parallel shifting of vectors. So to find the angle between A bar and B bar vector, so I'm just using the parallel shifting of vector concept. and I'm shifting the a bar vector. So this is the a bar vector. I'm just shifting the a bar vector like this. So what is the parallel shifting of vector says? Whenever the vector is displaced parallel by itself, its direction magnitude never changes. Have a look. Now this is the tail of the a bar vector. Okay, now this is the tail of the b bar vector. Now we have to find the angle between a bar and a b bar vector. Tail. Now this angle is valid. So have a look. This is a straight line. This is a straight line. Then the total angle is how much more? This is a 180 degrees. Okay. So from here to here, this is 180 degrees. So from here to here, the angle is alpha. Then remaining angle. So total 180. This is alpha. Then remaining angle is what ma? 180 minus alpha. 180 minus alpha. Similarly, if you want to find the angle between B bar and C bar vector, just you have to shift B bar vector. Now this is the tail of the B bar vector and C bar vector. Okay. This total angle is 180 degree. From here to here, angle is beta. So then remaining angle is what ma? 180 minus beta. This is what? 180 minus beta. The angle between B bar and C bar vectors is how much ma? 180 minus beta. Similarly, if you shift the C bar vector, now this is what? Shifted B bar vector. This is the tail. This is the tail of the A bar vector. Now angle between these two is how much ma? Angle between C bar and A bar vector 180 minus gamma. Are you getting? This total angle is 180 degrees. From here to here, the angle is gamma. 180 minus gamma. Then remaining angle is how much ma? 180 minus gamma. Likewise, you have to take the angles between A bar and B bar and C bar and A bar vectors, and you must take the angle between two heads or two tails of the vector. So now what is the angle between A bar and B bar vector? Is 180 minus alpha. Is how much ma? 180 minus alpha. So A bar square plus B bar square plus 2A bar B bar cos 180 minus alpha is equals to C bar square. Are you getting? Any doubts? Okay, sir. So A bar square plus B bar square plus 2A bar B bar cos 180 minus theta. Cos 180 minus theta is in second quadrant. In second quadrant, cos is minus. So it becomes minus cos alpha. Minus into plus minus cos alpha is equals to C bar square. So what we have to find? We have to find cos alpha. Just bring this term to that side and bring this C square to this side. So A square plus B square. So if plus C square comes to this side, it becomes minus C square. That is equals to minus 2AB cos alpha went to that side. It becomes 2AB cos alpha plus 2AB cos alpha. Are you getting? What we have to find? We have to find cos alpha. Then cos alpha is equals to, if 2AB comes to this side, it becomes A square plus B square minus C square by 2AB. Are you getting? Cos alpha is equals to A square plus B square minus C square by 2AB. So whenever you are writing the equations for cosine rule, so the angle between any two vectors is equals to, so whatever the adjacent sides of the angle, A square plus B square minus opposite side square divided by 2 into AB. That's it. So whenever you are writing the equation for this cos beta, then C square plus B square minus A square by 2BC. Whenever you are writing the equation for gamma, so what are the adjacent side? C square plus A square minus, what is the opposite side? B square. C square plus A square minus B square divided by 2AC. Are you getting? So likewise, you have to find cos alpha, cos beta, cos gamma. Now, if you wanted to find cos beta, here what we are doing? So A bar plus B bar is equals to, so case number 2, if you want to find a beta. So from this triangle, it is clear that A bar plus B bar plus C bar is equals to 0. Place A bar plus C bar here itself and bring this minus B bar to that side. It becomes minus B bar. After that, just apply magnitude. So A bar plus C bar is equals to minus B bar magnitude. After applying the magnitude, it becomes resultant of the two vectors. That becomes under root of A square plus C square plus 2AC cos theta is in B bar because it is in magnitude. So any term which is in magnitude, if it comes out from the magnitude, it becomes plus term. We have to square on either side. After squaring on either side, this term becomes A square plus C square plus 2AC cos theta is equals to b bar square. After squaring, this b bar term becomes b square. So where theta is the angle between A and C. What is the angle between A and C? The angle between A and C is what, ma? 180 minus gamma. So A square plus C square plus 2AC cos 180 minus gamma is equals to B square. So A square plus C square minus 2AC cos gamma is equals to B square. Okay. So now what we have to do to find cos gamma? Just bring this minus 2AB cos gamma to that side and bring this B square to this side. This term becomes A square plus C square minus B square is equals to 2AC cos gamma. So we need cos gamma. Then cos gamma is equals to A square C square minus B square divided by 2AC. So cos gamma is equals to C square plus A square minus B square by 2CA. We got now. So likewise, you can find the cos beta also. Okay. So next what we have to do? So just B bar plus C bar, place here itself only and bring this A bar to that side. It becomes minus A bar. So after that, you have to apply the mod. After applying the mod or magnitude, it becomes under root of b square plus c square plus 2bc cos theta is equals to minus a magnitude. After squaring on either side, it becomes b square plus c square plus 2bc cos theta is equals to a square. So after that, theta is the angle between b and c. What is the angle between b and c? 180 minus beta. Just substitute at the place of theta 180 minus beta. Then the term becomes b square plus c square minus 2bc cos beta is equals to a square. Now just bring this term minus 2bc cos theta to that side. It becomes plus term. And bring a square to this side. It becomes minus a square. So finally you will get b square plus c square minus a square is equals to 2bc cos beta. What you need? Cos beta. Then cos beta is equals to b square plus c square minus a square by 2bc you will get. And this is the proof for cosine law. Are you getting? Any doubts? Simple mathematics. Okay, just you have to remember this formula. So any triangle, whatever the angle they are given, so either it is A, B, C. Okay, now here itself we have alpha, here beta, here gamma. Then if you want to write equation for cos alpha, then cos alpha is equals to what are the adjacent sides of this alpha? C and B. Just write C square plus B square. What is the opposite side for this alpha? A minus A square divided by 2CB, 2BC or 2CB, whatever it is. Now if you wanted to write the equation for cos beta, so cos beta, what are the adjacent side with respect to beta? C and A. So C square plus A square minus, what is the opposite side? B square divided by 2CA. If you wanted to write equation for cos gamma, so cos gamma is equals, what are the adjacent sides with respect to gamma? A and B. Then A square plus B square. What is the opposite side? C square minus C square by 2AB. So likewise, whatever the angle they are given, just you should remember whenever you are writing the equation for alpha. So what are the adjacent sides? You have to check. So the adjacent sides for alpha, B and C. So just write B square plus C square. What is the opposite side? If B and C are adjacent sides, then immediately A becomes opposite side minus A square divided by 2BC. You have to write like that. Okay, now. So at any angle, everywhere they are given. Okay, now just you have to write the formulas like this. Is it clear? So this is what cosine law of vectors, right? So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So let us we discuss about sine law of vectors. Have a look. So what is the second one? The second topic is what, ma? Sine law of vectors. Sine law of vectors. Right. Have a look. What is the sine law of vectors? Okay. I'm taking the triangle again. Okay, so this is a side A of the triangle. Okay, and this is a side B and this is side C. The angle between B and C vectors, let us say an angle alpha. The angle between the C and A sides is a beta. The angle between B and A sides is gamma. Okay, then according to sine law of vectors, then we can get, so A by sine alpha is equals to B by sine beta is equals to C by sine gamma. C by sine gamma. So this is called a sine law of vectors in case of triangle. Okay. So have a look. side A divided by what is the angle opposite to the side A? Alpha, sine alpha. Side B divided by what is the opposite angle for side B? Beta, sine beta. That is equals to C. What is the opposite angle for side C? Gamma. Then you can write sine gamma. So right, have a look. Side A, side A. What is the opposite angle for side A? Alpha. Just write sine alpha. That is equals to B, side B divided by what is the opposite angle for side B? Beta. Just write sine beta. That is equals to C divided by what is the opposite angle for side C? Gamma, sine gamma. Okay, just to take the side. Okay, and divided by what is the opposite angle for that side? Just write in a sine terms, sine alpha. B by sine beta, C by sine gamma. So this is called what, ma? Sine law of vectors in case of triangle. Sir, we need proof, sir. We don't believe in this formula. We need proof for this formula. Okay, I will do the proof for this formula. Proof, right? So I'm taking the same triangle in the form of vectors. Okay, so have a look. This is a bar vector. This is the B bar vector. Now this is the C bar vector. A bar, B bar, C bar. These are the three sides of a triangle in the form of vectors. Okay. So here is an angle alpha. Here is an angle beta. And this is gamma. Okay. Now if you want to find the angle between any two sides, what we have to do? We have to take the angle must be in between two heads or two tails. Is it clear? For that, I'm just extending this A bar vector. Okay, and I'm just expanding this B bar vector. Okay, so I'm just expanding this C bar vector. Now the angle between two tails of the A bar vector and B bar vector is how much? 180 minus gamma. Okay, now the angle between B bar and C bar vector is how much? Here alpha is there, then you will get 180 minus alpha. Already we are discussed just a few minutes ago, ma. Okay, so now what is the angle between C and the A bar vectors? 180 minus beta. Okay, now let's proceed to find out sine law of vectors. Okay, right, have a look. So from this triangle it is clear that so the vector A bar plus the vector B bar plus the vector C bar is equals to 0 because there is no resultant side for this triangle. R bar is equals to 0. Is it clear? Any doubts? Okay. Now I'm just taking this equation. What is that? A bar plus B bar plus C bar is equals to 0. Okay. I'm just multiplying above equation with C bar vector. Just multiplying above equation with C bar vector. Have a look. A bar plus B bar plus C bar cross, not a multiplication, it is a cross. C bar is equals to 0 into C bar. I'm just multiplying C bar vector in either side. So 0 into C bar, the product of null vector with respect to vector gives a null vector. So have a look. A bar cross C bar, A bar cross C bar plus B bar cross C bar, B bar cross C bar plus C bar cross C bar, C bar cross C bar, that is equals to 0 into something vector, null vector, that means 0. A bar cross C bar, the vector product of A and C, the vector product of A bar and C bar, we can write magnitude of A into magnitude of C into sine theta, where theta is the angle between A and C, plus B bar and C bar, the cross product of B bar vector and C bar vector, magnitude of B into magnitude of C into sine theta, where theta is the angle between B and C vectors. Okay, so C bar cross C bar. So in a previous lecture, I told you that cross product of a vector itself, the cross product of a vector itself gives a null vector, gives a null vector. So now this term becomes 0 plus 0 is equals to 0, 0, 0, 0. Okay, right, have a look. Magnitude of A into magnitude of C. What is the angle between A and C side? So this is the side C, this is the side A. Angle between them is 180 minus beta. Sine of 180 minus beta minus, here I am taking minus instead of plus, I am taking minus. Why I am taking minus, I will explain. Okay, so magnitude of b into magnitude of c into sine theta, where theta is the angle between b and c. B, so this is a b bar vector and this is a c bar vector. What is the angle between them? 180 minus alpha. 180 minus alpha, that is equals to 0. Sir, why you are taken plus here? Why you are taken minus here? Have a look. In a previous lecture, I told you that whenever you are dealing with the vectors, what is the meaning of vector? A physical quantity having the both magnitude as well as direction. So this physical quantity is having the magnitude, something constant value b and c into sine 180 minus theta, something whatever it is. It gives constant value, and we have to check its direction. So it has a magnitude and we have to check the direction. So in a previous lecture, I told you that to find the resultant of cross product of any two vectors. So the resultant of cross product of any two vectors, we have to use right hand thumb rule. We have to use right hand thumb rule. Have a look from the figure, from this figure. So this is a c bar vector, okay, and this is a bar vector. What is the angle between them? 180 minus beta, and this is a smallest angle between a bar and a c bar vectors. It is clear. So have a look, this is a b bar vector, okay, and this is a c bar vector. And what is the angle between them? 180 minus alpha. So this is the smallest angle between two vectors. Now if you wanted to find the resultant of, if you wanted to find the resultant of a bar cross c bar vector, a bar cross c bar vector, by using right hand thumb rule, we have to place the fingers, we have to place the fingers on a first vector. So this is a bar vector, and rotate our fingers from first vector to second vector, first vector to second vector. Now the direction of the thumb gives the direction of the resultant vector. This is a resultant vector, this is a cross product. Okay, so now if you want to find the direction of this resultant vector, we are using the right hand thumb rule. Place the fingers towards the first vector and curl the fingers from first vector to second vector through a small angle, through a small angle. Then the direction of the thumb, then the direction of the thumb, have a look, a bar, c bar. I'm just curling my fingers. Now the direction of the thumb is into the plane of the board, is into the plane of the board. So have a look, if it comes to this b bar cross c bar, so this is a b bar vector and this is a c bar vector. Now to find the resultant direction, now we have to find the resultant direction. What we have to do? Place our fingers on b bar vector. So curl the fingers from first vector, curl the fingers from first vector to second vector, first vector to second vector through a small angle. Then the direction of the thumb, then the direction of the thumb, have a look, b bar vector, and just curling my fingers from b bar to c bar vector. Then the direction of the thumb, then the direction of the thumb. So what is the direction of the thumb? Outward, outward from the plane of the board, outward from the plane of the board. This is what, ma? Into, this is outward. So into means the resultant vector is absorbed by the plane, absorbed by the plane. So absolutely its magnitude will be increases plus. Okay, here. So the resultant vector is outward from the plane of the board, is outward from the plane of the board. So into, observe, added, added, outward, taken, taken, subtracted, subtracted. So that's why for the resultant of this vector b bar cross c bar, I'm taken minus because its direction is outward, outward. So it is subtracted. Into, the direction of the resultant vector is into, observed, added, plus. That's it. Is it clear? Any doubt? Okay. So magnitude of A, magnitude of C, sine 180 minus theta, sine 180 minus theta, second quadrant. In second quadrant, sine is plus. So you will get sine beta minus. So magnitude of B, magnitude of C, sine 180 minus alpha, sine 180 minus theta, second quadrant. In second quadrant, sine is plus. Okay, so just bring this term to that side. So magnitude of A into magnitude of C into sine beta is equals to magnitude of B into magnitude of C into sine alpha. So have a look. Here magnitude of C is there. Here magnitude of C is there. C get cancelled out. So A into sine beta is equals to B into sine alpha. So this is a plus term. Whether the plus term is in magnitude, it becomes plus only. Okay, now only if any negative term is there, if any negative term is there, it becomes positive. So in a magnitude a is a positive, then it becomes positive value itself. Okay, right, from this we can write. So bring this sine alpha to this side. It is in multiplication. If it is comes to this side, it becomes a by sine alpha. That is equals, here b is there. If sine beta went to that side, it becomes sine beta. So we got what, ma? A by sine alpha is equals to b by sine beta. If you wanted to prove this, have a look. Just I'm taking the same resultant vector. What is that? So a bar plus b bar plus c bar is equals to 0. Okay, at this time I'm just multiplying this equation with a bar vector. At this time I'm just multiplying with a bar vector on both sides. Same sigma. Okay, same sigma is repeated here. So a bar cross, cross a bar plus b bar cross a bar plus c bar cross a bar is equals to 0 into something vector, null vector 0. A bar cross a bar vector, its cross product itself gives what, ma? Null vector. It becomes 0. So b bar cross a bar plus c bar cross a bar is equals to 0. So b bar cross a bar, so magnitude of b into magnitude of a into sine theta plus magnitude of c into magnitude of a into sine theta is equals to 0. So where, what is the angle between b and a? So the angle between b and a is how much, one? 180 minus gamma, and we have to check the direction. Okay, now here we have b bar cross a bar. We have to curl our fingers from first vector to second vector, b bar vector to a bar vector through a small angle. So b bar to a bar, b bar to a bar. So the direction of the thumb is into, then it is plus. So angle between B and A is how much? 180 minus gamma. So magnitude of B into magnitude of A into sine 180 minus gamma plus CA. So CA, here C bar vector, here A bar vector. So what we have to do? We have to rotate our finger from C to A, not A to C, C to A, because C is our first vector. So this is our C bar vector. So we have to curl our fingers from C to A. Have a look. C bar to A bar vector. C bar to A bar vector through a small angle. C to A. C to A. Outward. The direction of the resultant vector is what, ma? Here, outward. So outward means it's a negative. Then minus into plus, it becomes minus. So magnitude of C into magnitude of A into sine. What is the angle between C and A bar vector? 180 minus theta. 180 minus beta is equals to 0. Okay. So magnitude of BA is nothing but BA. So BA. What is the sine 180 minus gamma? Sine gamma. Sine 180 minus theta, sine theta. Minus. Here C is there. Here A is there. Sine 180 minus beta. Sine beta is equals to 0. So BA sine gamma is equals to CA sine beta. Okay. So A get cancelled out, and B sine gamma is equals to, we got what, ma? C sine beta. So bring this sine beta to this side and bring this sine gamma to that side. It becomes B by sine beta is equals to C by sine gamma. So have a look. A by sine alpha is equals to B by sine beta is equals to C by sine gamma. Hence proved. Only the thing is, here you have to check the direction. Check direction. Okay. Any difficulty is there? Any problem? Okay, no problem is there na? Just pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So the last concept of today's lecture, that is a Lamis theorem, and the important theorem. We have the problems based on this concept. Okay. So what is our last concept of today's session? So that is what? Lamis theorem. Lamis theorem. Okay. Have a look. What is Lamis theorem? Okay. So here is a particle. Let us consider this is a point O. At a point O, there is a particle. Okay. So now the three forces, let us say this is a force F1, okay, and this is a force F2, and this is a force F3. Now these three forces are acting on this particle. These three forces are acting on that particle to keep it in equilibrium, to keep this particle in equilibrium. Then have a look, the angle between these two forces F2 and F3, let us say alpha. The angle between F3 and F1 force is beta. The angle between F1 and F2 force is gamma. Okay, so now according to Lamis theorem, whenever the three forces are acting on a particle to keep it in equilibrium, to keep that particle in equilibrium, then each force then each force is proportional to each force is proportional to proportional to the sine of the sine of the angle between the sine of the angle between other two forces, other two forces. Are you getting? So whenever the three forces are acting on a particle to keep it in equilibrium, then each force is proportional to, sine of the angle between other two forces, sine of the angle between other two forces. That means, have a look, from Lamis theorem, from this condition we can write, so F1, this is a force F1, is proportional to sine of the angle between other two forces. This is a F1 force. What are the other two forces? F3 and F2. What is the angle between them? Alpha. That's it. F1 by sine of the angle between other two forces, that is alpha. That is equals to, if you want to write an equation for F2, okay now, force F2, then F2 is equals to, so have a look, what is the angle between other two forces? F3 and F1. These are the other two forces. What is the angle between them? Beta. And this force F2 is proportional to sine of the angle between other two forces. That is beta. Are you getting? Third one. So F3 divided by. So this is a force F3. Any force, each force is proportional to sine of the angle between other two forces. F2 and F1 are the other forces. What is the angle between these two? Gamma. That's it. So this is called what? Lamis theorem. This is called what, ma? Lamis theorem. Are you getting? Any doubt? Okay. So note number one. So first note, single force, single force cannot, single force cannot keep the particle, keeps the particle in equilibrium, in equilibrium. So a single force never keep the particle in equilibrium. Okay, so second point, minimum number of minimum number of minimum number of equal minimum number of equal and and coplanar forces required to keep the particle keep the particle particle in equilibrium are two. How many equal and coplanar forces? Minimum number of equal and coplanar forces are required to keep the particle in equilibrium. Two. Two equal and coplanar forces are keep the particle in equilibrium. Okay, that's it. So third point, minimum number of non-equal non-equal here equal here non-equal and coplanar forces are required to keep the particle in equilibrium are three. Okay now, so non-equal but coplanar. What is the meaning of coplanar? All the forces are acting in a same plane, or all the vectors which are acting in a same plane, such type of vectors or forces are called what, ma? Coplanar. So the forces must be act in a same plane, and although they are non-equal force, 3 newtons, 4 newtons, 5 newtons, whatever it is, so minimum number of forces required to, okay now, keep the particle in equilibrium, although if they are non-equal, how many required? 3 forces are required to keep the particle in equilibrium. Okay, so fourth one, minimum number of or non-equal, equal or non-equal and non-coplanar, non-coplanar, either equal or non-equal or non-coplanar forces are required to are required to keep the particle in equilibrium are four. So equal or non-equal forces, non-coplanar forces are required to keep the particle in equilibrium. How many? Four. Here, three, two. One force never keep the particle in equilibrium condition. Is it clear? Any doubt? Right. Just pause the video and write the notes. We will solve some example problems. Okay. So please pause the video and write the notes. 3, 2, 1, go. Right. So have a look. This is a example problem based on Lamis theorem. Okay. So have a look what they are given. So in the given figure, the tension in the string OB is how much? 13 newtons. So we know that the tension force is always acts away from the mass. So always acts away from the mass. Then the tension in this string, let us say this is a T1. So how much they are given? 30 newtons. This is 30 newtons. Okay. So find the weight, capital W. What they are asking? W is equals to how much we have to find, and then the tension in the string OA. So we have to find the weight acting on the object. So always weight acting on the particle in downward direction. We know that. So we have to find how much of weight is acting in downward direction, and the tension in the string OA. So let us say this is a tension T2. So T1 they are given how much? 30 newtons, and we have to find the tension in string OA and the weight of the object. Okay. So just pause the video and try the solution by using Lamis theorem. Based on this condition, we have to solve this solution. Okay. So just pause the video and try the solution. 3, 2, 1, go. So what is Lamis theorem says? So whenever the three forces are acting on a particle to keep it in equilibrium, then each force is proportional to the sine of the angle between other two forces. Have a look. So the gravitational force acts in downward direction. So solution. So this is a point O. Okay now. So at this point O, the weight or the gravitational force, the weight of the object is acting in a downward direction. Downward direction. So the tension force on the string acting in this direction, that is T1 is equals to how much? 30 newtons. Okay. And the tension T2 is acting in this direction. Have a look how many forces are there? 1, 2, 3 forces are there. So now they are given one angle. What is that? So this angle they are given, and this angle is how much? 30 degrees. Okay. Now just we have to find the angle between these two forces, and these two forces. That means the angle between tension T1 and T2, T1 and W, T2 and W is equals to how much we have to find. The finding we have to substitute in this formula, we will get the answer. That's it. Are you getting? Are you got the idea? Right. Now pause the video and try the solution. 3, 2, 1, go. This end is like this. Okay. And this end is like this. Okay. So this angle is how much? 30 degrees. This angle is how much? 30 degrees. Now the angle between these two lines. Have a look. This is a straight line. This is a straight line. Now the total angle is how much? 180 degrees. 180 degrees. From here to here, 30. Total angle is 180. Then this angle is how much? 180 minus 30. That is equals to 150 degrees. Are you getting? So this total angle is 180 degrees. From here to here, 180 degrees. They are given 30 degrees with the vertical. How much? 30 degrees. Then this remaining angle, 180 minus 30 is equals to how much? 150. Now we got the angle between T2 and W. Now what we have to find? We have to find angle between T1 and W. T1 and W. Have a look. These two are perpendicular to each other. These two are what? Perpendicular to each other. Then theta is equals to how much? 90 degrees. So we got the angle between T1 and W. Now what we have to find? We have to find the angle between T1 and T2. Tension T1 and T2. Have a look. This vertical line and this T1 line are perpendicular to each other. These two are what? Perpendicular to each other. Then this angle is 90. So from this vertical line and T1 line, the angle is 90. From here to here, angle is 30. Now, what is the angle between T1 and T2? So, 90 plus 30. That is equals how much, ma? 120 degrees. Are you getting? Is it clear? Right. Have a look. So, this is a given diagram. So, this is W. This is tension T1. That is 30 newtons. Okay. So, this is the tension T2. So, what is the angle between T1 and T2? 120 degrees. What is the angle between T2 and W? 150 degrees. What is the angle between T1 and W? These are perpendicular to each other and theta is equals to 90 degrees. So we have the three forces and we have the angle between them. Then we can find the answer. Okay. So according to Lamis theorem, what is Lamis theorem says? Each and every force is proportional to the sine of the angle between other two forces. So W by W divided by what is the angle between other two forces? 120 degrees. Sine 120 degrees. That is equals to T1 divided by. So this is the T1. So what is the angle between other two forces? Sine of 150 degrees. That is equals to T2 divided by what is the sine of the angle between other two forces? This is T1. So the other two forces are T1 and W. What is the angle between them? 90 degrees. That's it. Okay. So W by what is the value of sine 120? Sine 120 given as sine of 90 plus 30. Okay. So that is equals to what is the value of T1? T1 is equals to 30 newtons divided by sine 150. Sine 150 can be written as sine of 90 plus 60. Sine of 90 plus 60. That is equals to T2. We have to find divided by what is the value of sine 90? 1. Sine 90 value is how much, ma? 1. Just equate these two equations. Just equate these two equations. You will get W and the T2 values. Okay. So have a look. W divided by sine of 90 plus theta. Sine of 90 plus theta in second quadrant. In second quadrant, sine is positive. Sine 90 plus theta at 90 degrees. Sine becomes cos 30 is equals to 30 divided by sine 90 plus theta cos 60 degrees. Okay, so cos 30 degrees and cos 60 degrees. Have a look. 30 divided by sine 90 plus 60 cos 60, that is equals to T2. Are you getting, ma? Okay. So W by what is the value of cos 30 degrees? The value of cos 30 degrees is root 3 by 2. That is equals to 30 divided by what is the value of cos 60? 1 by 2. So 30 by what is the value of cos 60? 1 by 2. That is equals to T2. Okay. So have a look. These two get cancelled out. And if 3 went to that side, you will get W is equals to 30 root 3. W is equals to how much, ma? 30 root 3. Are you able to see the board? Okay, it is clear. So, right, we have to find T2. Then T2 is equals to, if 2 comes to numerator, 230 is a 60 newtons. So, W is equals to 30 root 3 newtons and T2 is equals to 60 newtons. Okay, right. So, these are the answers. Are you getting how to find the given forces by using Lamis theorem? Okay, is it clear? Right. So, just pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right, have a look. I'm just doing the example number 2 and example number 3 based on our concept Lamis theorem. Okay, so have a look. What is the example number 2? So capital A and capital B are the two pegs and separated by 13 centimeters. So capital A and capital B are the two pegs. The distance between them is how much? 13 centimeters. A body of weight capital W, a body of weight capital W is suspended from point A and point B. Somewhere in between these 2 points, they are suspended one weight. Okay, using a thread of length 17 centimeters. They are just suspended a weight of a body capital W in between capital A and B. What is the length of the thread? So 17 centimeters. Have a look. So 12 centimeters and 5 centimeters. 12 plus 5, 17 centimeters. So the total length of this thread is how much, ma? 17 centimeters. Okay, sir. Then find out T1 and T2. Then find out T1 and T2. So we have to find tension T1 and T2. So this is a, have a look. This is a triangle 5 centimeters, 12 centimeters and 13 centimeters. Now what we have to find according to Lamis theorem? Just we have to find the angle between T1 and T2, T2 and W, T1 and W. After that we have to substitute in formula. Okay, so T1 by sine alpha is equals to T2 by sine beta is equals to W by sine gamma. Then you will get the answer. But here the triangle is 5 centimeters, 12 centimeters and 13 centimeters, and the angle between the forces is not given. We have to find. Okay, right. Solution. So we know about a 3 4 5 triangle. We know about 3 4 5 triangle. What is a 3 4 5 triangle? So this is a 3 4 5. This is 90 degrees and this is a 37 degrees and this is 53 degrees. We know about this triangle. But there is also one more triangle, that is a 5 12 13 triangle. 5 12 13 triangle. What is the 5 12 13 triangle, sir? How many triangles are there, sir? Okay, there is a lot of triangles. Okay, now so whatever the triangles used in our subject, just we will discuss about the triangles only. Okay, right. So this is a 5 12 and a 13 triangle. Okay, important one, right? So have a look. The angle between 5 and 12 sides is 90 degrees. Is how much? 90 degrees. Angle between 12 and 13 side is 23 degrees. How much? 23 degrees. And the angle between 13 and side 5 is 67 degrees. So 23 plus 67, 90. 90 plus 90. How much? 180 degrees. So this is all. 5, 12, 13 triangle. You have to remember the angle between the side 5 and 12 is how much? 90 degrees. So the angle between 12 and 13 side is 23 degrees and the angle between 13 and 5 side is 67 degrees. So please note this triangle and the important triangle. Okay, already we have discussed about a 3 4 5 triangle and one more triangle we got. What is that? 5 12 13. 5 12 13. 5 12 13. So 90 degrees. Okay, so this is how much? 23 degrees. Actually there is a 22 point something is there. I'm just taken 23 degrees and this is a 67 degrees. Okay, so from this triangle it is clear that the angle between side 5 and 12, side 5 and 12 is how much? 90 degrees. This is a 90 degrees. Okay, right. Have a look. Here I'm taking to get the answer. To get the answer, here I'm taking the angle between side 5 centimeters and 13 centimeters as an angle theta. Now I'm not taking 67 degrees. I'm just taking the angle between these two sides as theta. Okay, what we have to find? We have to find the angle between T1 and T2, T2 and W, and T1 and W. I'm just drawing one vertical line like this. Okay, vertical line, right? So what is the angle here? This is a 90 degrees. Okay, if this is 90 and this is theta, as we know that the total angle formed by the triangle is how much? 180 degrees. In this 180 degrees, here is an angle theta. So this is a 90 degrees. Okay, now I want to find the angle from here to here, T1 and this vertical line. Let us say this is x plus x. Have a look. X plus 90 plus theta. X plus 90 plus theta is equals to how much? 180 degrees. The total angle formed by the triangle. So now just bring this 90 to this side. If plus 90 comes to this side, it becomes minus 90. 180 minus 90, you will get 90 is equals to theta plus x. What we need? We have to find x. Then x is equals to, if theta comes to this side, it becomes 90 minus theta. It becomes how much? 90 minus theta. Now the angle is here. Is how much? 90 minus theta. Have a look. This total angle, have a look. This vertical line is how much? 180 degrees. This total angle is how much? 180 degrees. From here to here, we have 90 minus theta. We have 90 minus theta. Then what is this angle? Have a look. This total angle is 180 degrees. This total angle. From here to here, we have 90 minus theta. We need this angle. Let us say this is y. So plus y. Have a look. Y plus 90 minus theta. Y plus 90 minus theta is equals to how much? 180 degrees. Just bring this 90 to this side. So 180 minus 90, you will get 90. That is equals to minus theta plus y. Okay, what you need? You need y. Then y is equals to, bring this minus theta to this side. It becomes 90 plus theta. Now what is this angle, ma? 90 plus theta. 90 plus theta. Okay, sir. So have a look. This total angle is 90. This total angle is 90. Black color line, ma. 90. From here to here, 90 minus theta. Total angle is 90. So this is a 90 minus theta. Let us say this required angle is z. So total angle 90 degrees. That is equals to 90 minus theta plus z. is there. So have a look. 90 is equals to 90 minus theta z. So bring this 90 to this side. It becomes 90 minus 90 is equals to minus theta plus z. So 90 minus 90 is 0. If minus theta comes to this side, it becomes plus theta is equals to z. So z is equals to, we got how much more? Theta. Okay, have a look. This total angle, this vertical line, this total angle is how much? 180 degrees. From here to here, angle is theta. So this is theta. This is total angle is 180. Then required angle, this one is equals to how much more? 180 minus theta. Are you getting? Just mathematics. So pause the video and go back and again listen once. You will get the clarity. Which angle, what angle, where exists. Okay, right. I'm going to rub this part. So pause the video and write this part. Okay, and just draw the diagram clearly in this side. Okay, right. Pause the video and write this part. 3, 2, 1, go. Have a look. So what we got? This is A, this is B. Okay, so W, this is our T2, this is T1. Okay, so angle between these two is 90 degrees. Okay, now the angle between T1 and W, the angle between T1 and W, how much? 90 plus theta. Okay, the angle between T2 and W, the angle between T2 and W, how much? 180 minus theta over. We will get the answer ma. Okay, so T1, this side is how much? 5 centimeters, and this side is how much? 12 centimeters, and this is 13 centimeters. So we have taken this as an angle theta. Okay, this is an angle theta. Is it clear? Right. According to Lamis theorem, we can write what ma? So W by, so this is a gravitational force acting in a downward direction. Sine of the angle between other two forces. Sine of the angle between other two forces is how much? 90 degrees. That is equals to T1. T1 divided by sine of the angle between other two forces. Sine of the angle between other two forces. That is T2 and W is how much? 180 minus theta. That is equals to T2 divided by sine of angle between other two forces is how much? 90 plus theta. Okay, so W by sine 90 degrees is how much? 1. That is equals to T1 divided by sine 180 minus theta. Sine 180 minus theta, second quadrant, sine 180 minus theta, sine theta. So we got T1 by sine theta. Okay, so W by, again I'm equating these two equations. W by 1 is equals to T2 divided by sine 90 plus theta. Sine 90 plus theta, second quadrant. In second quadrant, sine is plus, sine 90 plus theta, cos theta. Sine 90 plus theta, cos theta. So what we got? W is equals to T1 by sine theta, and we got W is equals to T2 divided by cos theta. Okay, so W is equals to T1 divided by, have a look from this triangle, sine theta, sine theta. So here I am drawing. So this is an angle theta, this is 13, this is 5, and this is 12. So from this triangle, sine theta is equals to, we can write what ma? Sine theta is equals to opposite side by hypotenuse. Okay, so what is hypotenuse? What is hypotenuse? 13 is the hypotenuse. What is opposite side? 12 is the opposite side. So sine theta is equals to 12 divided by 13. So what is sine theta? 12 divided by 13. Are you getting? Sine theta is equals to opposite side by hypotenuse, 12 by 13. So W is equals to T2 divided by cos theta. Cos theta, adjacent side. Adjacent side. What is that? Cos theta is equals to adjacent side by hypotenuse. What is adjacent side? 5 divided by, what is hypotenuse? 13. So cos theta is equals to, we got how much more? 5 by 13. 5 by 13. Just bring this term to this side. Then T1 is equals to 12 into W, 12 W divided by 13. And T2 is equals to, you will get 5 into W, 5 W divided by 13. So 12 W by 13, 5 W by 13. Option C is our answer. Okay, right. So likewise you have to do the problems. Any problem is there, just you have to know how to find the angle between given two forces, then you can easily get the answer. Okay, just you know what, if you are practicing more, okay, now if you are practicing more, then you will get easily understood. Okay, you can easily, by seeing only you can say that So this is theta 90, then this is 90 minus theta. So this total angle is 90 degrees. So from here to here 180, then remaining angle is how much? 90 plus theta. From here to here theta, then remaining angle between these two is 180 minus theta. So if you are practice more, then you can understand by seeing the figure only what is the angle between given two forces. Okay. So please practice, practice, practice. Practice makes you perfect. That's it. Okay. Are you understood? Any doubts? Let us see the next question. So what they are given? A 10 kg body is suspended by a rope. Okay, a 10 kg body is suspended by a rope, is pulled by means horizontal force to make a 60 degrees by rope to the vertical. So the horizontal force is, that means, have a look, they are taken one object of mass, how much? 10 kg, and they are suspended it like this. Okay, now what they are doing, they are just applied a horizontal force on that object. So what happened after applying the horizontal force? They are pulled this object by making an angle 60 degrees with the vertical. So with respect to the vertical, now this object is making 60 degrees after applying the force capital F, horizontal force capital F. So what they are asking, the horizontal force capital F is equals to how much? They are asking this. Okay, so please pause the video and try the solution. Pause the video and try the solution. 3, 2, 1, go. Have a look. As we know that the tension force is always act away from the object. Okay, this is the mass of the object, and the tension force is acts away from the mass. So in this condition also the tension force is acts away from the object. Okay, any problem? Okay, I'm just going to draw one vertical line here. Okay, this is a vertical line. Always you should remember, always you should remember, if any shape is like this, okay na, if any shape like this, if this is an angle theta, if this is an angle theta, then this is also an angle theta. If this is theta, then this is also an angle theta. Have a look, the shape is like this. If this is 60 degrees, then this is also 60 degrees. Are you getting any doubts? Okay. So as we know that on any object, the gravitational force is acting in a downward direction, or the weight of the object is acts in a downward direction. So what is the weight of the body they are given? W is equals to 10 kg, and it is acting in downward direction. Okay. So have a look. What we have to find? We have to find a capital F, horizontal force. And just using the concept of resolution of vectors, I'm using the concept of resolution of vectors to find capital F, to find capital F. Have a look. This is a force tension T along theta side, along theta side, along theta side. You will get what, ma? This magnitude into cos theta, along theta side, cos theta. Now perpendicular to this, now perpendicular to this, perpendicular to this, you will get this magnitude into sin theta. Already we are discussed in a resolution of vectors in 2 dimension. We have discussed all these things now. Okay, right. So from this diagram, it is clear that, have a look. This is a capital F, horizontal force applied. So what is this? This is a T sin theta, and this is a T cos theta. In a downward direction, the gravitational force or weight of the body is acting how much? 10 kg. Okay, have a look. These two are equal and opposite forces. These two are equal and opposite forces. Then we can write T cos theta is equals to 10, and capital F is equals to T sin theta. Capital F is equals to T sin theta. So T cos theta is equals to 10. T sin theta is equals to capital F. What is theta? What is theta here? Theta is nothing but what, ma? Theta is equals to 60 degrees. Okay, just substitute here. T cos 60 is equals to 10. So what is the value of cos 60 degrees? 1 by 2 is equals to 10. So capital F is equals to T sin 60. What is the value of sin 60? T into root 3 by 2. So this is the value of sin 60. Okay. If 2 went to this side, it becomes 2 tens are 20. So T is equals to 20 newtons we got. So the tension in the string is equals to how much, one? 20 newtons. Just substitute T value here. Capital F is equals to 20 into root 3 by 2. So 2 ones are 2 tens are. Then capital F is equals to, we got 10 root 3 newtons. So option C is our option, correct option. Okay, right. So likewise, you have to solve the problems. Okay, ma. Any doubt? Right. So pause the video and write the solutions. Pause the video and write the solutions. 3, 2, 1, go. Right. So this is the end of the today's lecture. I hope that you are understood the concepts. Okay, what is sine law? What is cosine law? What is Lamis theorem? So how to solve the problems based on Lamis theorem and using the resolution of vectors. Okay, right. So this is the end of the today's lecture, and keep studying and keep practicing. Okay. So every single minute, every single second, every single hour, every single day is important to achieve your goal. Okay, so keep practicing, don't waste your time, right? This is a time to signing off. So this is Rakesh signing off. Jai Hind.